do we do with the I?
Okay, let's simplify square roots of negative numbers in terms of I. So we'll start with review on how to simplify radicals. So let's use radical 300. So I want to find the largest perfect square root. So that will be radical 100 times radical 3, which equals to 10 radical 3. So let's do a negative number square root. So let's use radical negative 36. So that equals to radical 36 times radical negative 1. So radical 36 just equals to 6, and radical negative 1 equals to I. So that just equals to 6I. So let's move on to a more difficult one, which is this one. So we'll do the top first, and radical negative 300 equals to radical 100 times radical 3 times radical negative 1 all over radical 49 times radical negative 1, and that will equal to 10I radical 3 over 7I. So that's the final answer. And let's move on to an equation now, and to get 64 to the other side, we'll just turn it to negative. So x squared equals to negative 64. To get rid of this exponent, we'll take the square root of both sides. So square root of x squared equals to square root of negative 64. So x equals to 8i because the radical of 64 times radical negative 1 will equal to 8i. Next, we'll do simplifying powers of I. So the power of 1 for I to the first will just be I to the second equals to negative 1, I to the third equals negative I to the fourth equals 1. But what if we get to higher exponents? Then we can divide it by 4, and if the remainder is 0, then the answer is just I to the 0 or I to the fourth, which is just 1. And if the remainder is 1, then the answer is I to the first, and the answer is just I. If the remainder is 2, then the answer is I to the second, which is just negative 1. And if the remainder is 3, then the answer is just I to the third or negative I. So let's move on to an example. So let's simplify I to the sixth. So I to the sixth, if you divide it by 4, the remainder will be 2. So if the remainder is 2, the answer will be I squared, which is just negative 1. So the answer is negative 1. Let's do a higher degree in power. So 56, if we divide that by 4, it just equals to 14. So the remainder is 0. So if the remainder is 0, the answer is I to the 0, which is just 1. So the answer is 1. So let's move on to a larger equation. So let's first just divide each one by 4. So 14 divided by 4, the remainder would just be 2. 15, the remainder would be 3. 16, the remainder would be 0. 17, the remainder would be 1. So if the remainder is 2, then the answer would be I squared, which is just negative 1. And for a remainder of 3, then the answer would be I to the third, which is just negative I. For 0, the answer would be I to the 0, which is just 1. And for 1, the answer would be I to the first, which is just I. So each value cancels out because negative 1 plus 1 is just 0. And negative I plus I is just 0. So 0 and 0 just equals 0.
Graphing complex numbers.
An example would be 3 plus 4i. So that's just 3 and 4. So when it has the I, it's just the y coordinate. So let's start off with a simple one. So negative 3 plus 2i. That's simply just negative 3 comma 2. So I'll go over to negative 3, and then I'll find the 2. So I'll find where they meet, which is right here. And I'll draw the vector from the 0 point. So I'll have to go like that. So that's the answer for that one. So we'll graph two vectors on the same thing so we're going to add them. So negative 2 plus 4i, that's just the coordinates of negative 2 comma 4, and the coordinates of 4 comma 1. So let's plot that first. Negative 2, 4, it's over here, and we'll draw it from the origin. And 4, 1 is right here, and we'll draw that from the origin. So let's make a parallel line to make a parallelogram, which will help us find where they are added. So this is the point where they meet, which is 2 comma 5, and the resultant is the answer, which tells us that right here the answer to the addition is the vector. So over here we'll do the next problem, and it says subtract, so we're going to change it into adding. So if we take, it says subtract negative 1 plus I from 3 plus 2i, so it'll be 3 plus 2i minus negative 1 plus I. So we'll distribute the negative sign, so that will just be 3 plus 2i plus 1 minus I. So we'll turn these into coordinates. So it's just 3 comma 2 and 1 comma negative 1. So let's plot those. 3 comma 2 is right here. 1 comma negative 1 is right here. So we'll draw it from the origin. It looks like a rectangle. So we'll draw the parallel line and make a parallelogram. So the answer would be where they met from the origin to that spot, and that would equal to 4 comma 1. Simplifying and operations of complex numbers. In order to simplify a complex number, you have to change it to a plus bi form, which is standard form. If you find an I in the denominator of a fraction, you have to get rid of it by seeking the conjugate. So this first example here is actually a denominator and a conjugate. So let's FOIL that. So 6 times 6 equals 36, and 6 times negative 7i, which is just negative 42i. 7i times 6 is plus 42i, and 7i times negative 7i is negative 49i squared. So we see that these two cancel out, so that's why we change the sign in the middle, so that it'll cancel out, so that we won't have any more I in the bottoms, because I squared will turn into a negative 1, so that will just be plus 49. So that equals to 55. So let's move on to an example which needs to get a conjugate on the bottom to fix the problem. So we would have to multiply the top and the bottom by the same number, so we have to multiply the top and the bottom by the conjugate. So let's do that, and I'll multiply it out. So 4 minus 3i over 16, and now we don't have to multiply the very inner and the very outer, because as we've seen in the first example, they just cross out. So 3i times negative 3i is just plus 9, because 3 times 3 is 9, and the I squared changes the negative back to positive. So the final answer is just 4 minus 3i over 25. So let's move on to one with radicals inside it. So let's multiply the bottom and the top by the conjugate of the bottom. So 2 rad 7 minus I. So let's multiply that out. So let's do the bottom. So it would equal to 28 plus 1 because 2 times 2 equals 4, and rad 7 times rad 7 is just 7, so 4 times 7 is 28. And we just have negative I times I, which would equal to I squared, and we have a negative, so negative 1 times negative 1 is just 1. So let's multiply the top now. So the top would be 42 because 2 times 3 is 6, and rad 7 times rad 7 is 7, so 7 times 6 is 42. So let's continue. So 3 rad 7 times negative I is just 3I minus rad 7, and negative 2I times 2 rad 7 is negative 4I rad 7, and negative 2I times negative I equals negative 2. So let's just simplify that out, and we get 40 minus 7I rad 7 over 29. Okay, let's move on to adding them, which can be a little more difficult because they have different denominators and we have to get them to be the same. So for this one, we have to multiply each of the fractions by the bottoms, the denominators of each of the other ones. So this one will have to be multiplied by 1 minus 3I, and this one will have to multiply by 1 plus 3I. So let's multiply the bottom ones by the opposite one, so I'll just do that down here. So 1 times 1 is 1, negative 3I plus 3I minus 9I squared, so that equals to 1 plus 9 equals 10. So our denominator is now 10, so we'll get that, and we'll multiply these and distribute them so that we can get the top. So 2 times 1 is 2 minus 6I plus 5 plus 15I, and our final answer will become 7 plus 9I all over 10. That's the final answer.